Welcome back everyone. So we've got a different video update today. I want to take you through a build progression update on the mechanical build, but also some of the electronics that I've been working on. You see in front of you the completed Rover build. So this is really exciting. I have completed the Rover build this week, about 2 days ago. And it's fully mechanically complete as far as all of the linkages and the things that need to be in place for this to have its first test drive. It's all done. So we've got a longer chassis now. This was 400 millimeters long. It's getting quite large. I was a bit shocked to see how big it was, to be honest, but it's now 450 millimeters long. We have reprinted 2 brackets for servos. These servos are mounted in such a way that they can actuate the bell crank steering linkage. I've got M3, I guess, sized parts here. So this is M3 and this is M4. M3 for the servo push rod, overkill, but these are 30 kilogram centimeter servos. Could have got away with like M2.5 or something, but whatever. Couldn't get quality parts, and these are stainless steel. So I've got M3 here to my bell crank that's printed. Obviously the servo bracket is printed, and these are M4 parts, and the M4 parts push the steering arm, which are connected to the motor housing upright, which, as you remember, has a kingpin around it, a split kingpin around the motor volume, and then that links off to the axle and so on, right? So you saw that corner last time, and so I've built out those 4 corners, and it's a modular design. It looks super swanky in my opinion, just the combination of black printed PLA. I just went with PLA in the end, not PETG-HF. I got better quality prints with, I guess, stronger settings like 6 walls and various other bits and pieces, like more infill. They're stronger, stiffer parts, and I just like the print quality. That black plus the aluminium here plus the stainless steel, I think just looks super swanky. And I'm really happy with the overall design. Obviously, I'm not happy with the through bolts and the fact that I've got bolts that are way too long. But overall, it's it's quite a large machine, but it's stable. It feels robust. It feels really stable, and I'm really happy that this is kind of where I've arrived at. Notwithstanding the geometry issues I talked about, like the scrub radius. To do this, actually, this is worth talking about. Since the last video, I had the steering rod shortened. I've had the forks, as I'm calling them, extended by about 10 millimeters. So the kingpin is now 10 millimeters closer to the wheel. So we've got a 70 millimeter scrub radius instead of 80 now. And the only reason I did that was so that I could get an Ackerman steering geometry going. So let's look at the front end here. Now, if I can control this this camera. Now, what I wanted to achieve was Ackerman geometry for what I'm calling reverse phase steering. I don't know if that's the right terminology, but reverse phase steering means that I can do tighter turning circles and I have all 4 wheels steering at the same time. So let's say this is steering to the right, then the rear is steering to the left, and that means that I can have a tighter angle, steering angle for the wheelbase. However, for Ackerman steering, what you want is let's say we're right, you want this wheel to prescribe a tighter arc than this one because it's turning on a smaller turning circle, right, based on the width of the vehicle. And for that to happen, you need the kingpin and the steering arm to effectively, if you draw a line between those, you need those to intersect. Well, if it was a front steering vehicle only, you'd want them intersecting somewhere near the rear axle, in the chassis center line. But in my case, I want both front and rear to be steering, and so for Ackerman steering in that situation, I want something close to these 2. If I draw a line between these 2, kingpin and steering arm, I want it intersecting roughly in the middle of the chassis, which is what I've configured here. So to do that, I had to bring the steering arm closer. I had to push this out a little, and I had to shorten the steering rod, as I'm calling it, or steering bar. And nothing else changed about the geometry in terms of where the servo sits and so on and so forth. So that's all fine. And then I had some issues with, oh dear, I had some issues with some stack clearance. Because I'm using the default servo horn that comes with these servos, I had to stack the push rod and the ball link here about 4 millimeters down just to clear everything and make sure that was all fine and dandy. So that's all working now. Now I've just knocked over my PCB that I wanted to show you all. So let's have a quick look at that. So let me just rebuild the bits. So I've basically done a dry fit here. I think that's the correct terminology. I'm effectively just making sure that I've got all the right parts for my PCB. So exciting thing for me is this is my very first PCB, at least for this project. And generally speaking, it's my first PCB ever. It's the power distribution board for the Rover. And so what it does is its sole job is to manage power from batteries to various and create regulated rails for the various parts that the robot will need. And so I've used Wago connectors. I think that's how you say it. Wago, whatever, Wago connectors. I reckon they look really cool. They're sprung-loaded lever things, so they will make really good contact and hold that contact. And they're the orange ones. I've got 2 different sizes based on the current that is required. And then I've got some screw terminals here. I've got 2 buck converters, a 12 volt and a 5 volt buck converter. And then at the top here, I've got some, I won't go through it now, but I've got some power safety circuitry, if you like, and also for this one. So the board is broken into kind of like 2 sections. There's the first battery. These are 6S batteries, which means they'll normally do somewhere between 21 and, like, let's say 20 to 26 volts, 21 to 26 volts, let's say around 24 volts. So the first battery, 6S battery, comes in here, goes straight into a fuse, then it goes off in, and the fuse is, I've got a loop with a blade fuse, like an automotive blade fuse, and I'll have that for the top and the bottom. And that just will be chassis mounted or mounted on a 3D bracket that I will design. And then likewise, it goes straight into a switch, and the switch will also be chassis mounted. And I've got these nice big rocker switches, and they illuminate when they're on. So this will be a red switch and this will be a green switch, and the colors will become obvious later. And so current flows obviously from battery into fuse, or through fuse into switch, into this power circuitry here. I haven't actually soldered the MOSFETs. They're surface mount, and I have to do that. And then through into 2 RoboClaws, and the RoboClaws are 24 volts, so that will power, RoboClaw 1 will, let's say, will power the 2 front motors on the front of the Rover, and RoboClaw 2 will power the 2 motors at the rear. So across those 2, I will have 4 motors being powered at 24 volts, and then I have 2 bucks. Now the 12 volt buck creates a regulated 12 volt rail here, which is output for the servos, and that goes to the servo bus adapter, which then feeds the 2 servos, and those servos obviously sit here and here. And so I'm going to build a stack in the middle. I will have a battery tray here with the 2 6S batteries laterally, and then I'll have the power board above that, and then I'll just stack circuitry above that as I need it. It means that everything's central and I've got good access for cabling, and I'll have to run cabling across and down the chassis, and I'll make sure that's all nice and neat. But anyway, so that servo power line or power rail will go out to the bus adapter and to the servos. And then the second buck here is a 5 volt. That will power what I'm calling the control board, which I'm currently designing. The control board will go and feed, this will basically just go out to another board that has the ESP32 on it and the IMU and a few other pieces on that board. And I've separated that, I wanted a separate power management module, if you like, and then a separate control logic module. And so that's the point of designing this way. So that's the top part. And now the bottom part, same deal, same sort of power circuitry. The power management is different. Like it's polarity protection and reverse current protection, but it will go, and it's an ideal MOSFET arrangement, so there's very low forward voltage drop, and then that will go through to this Wago connector, which will go off board, off to a chassis mounted 19 volt regulator, and that 19-volt regulator will go off to, I'm hoping, an NVIDIA Jetson part, which will be a separate board that I'll do later when I need it, when I need the CUDA and compute capability. I don't need it immediately. I'll just do basic odometry and some really simple things there. So I just need the ESP32 and these top rails here for actuation. So that's the plan. So this will be a red switch for just actuation and control, and then this will be a green switch for NVIDIA because, you know, NVIDIA is green. Right, that's the joke. So anyway, so this is looking really cool, I think. Obviously I need to build it and I need to solder it and just do the testing, but I'm really happy with the quality of what was produced. It's all the parts are over here. So JLC PCB did the build for me, and I've got a bunch of other components here that I haven't used yet. But that will be the very first board that I bring up and test. And that will then sit, well, I'll have the battery module here, I'll have one 6S battery, and then I'll have the power board mounted above it, and that will feed all of the various components. And I'll probably just have the ESP32 and, yeah, just the ESP32 actually just hanging directly off here somehow. I'm not going to build a control board initially. I'll just get this thing up and running and have it tested with power circuitry working with a 6S battery, actuating the entire Rover chassis, and then happy days. The other little piece here I want to talk about, I've got these circlips now that I don't know if you can see very well, but they are, if I zoom in perhaps that might help. Oh, okay, 1 second. So if I zoom in, these circlips are just retaining the inner bearing, or the inner race, if you like, on the bearing. And I've got a spacer here. This is all 3D printed stuff, so it's not, you know, it's not as robust as it needs to be. But it's like if I apply a bit of pressure here, yeah, I can generate a bit of give, but it's pretty robust. Obviously the chassis is, but you know, the main component that is kind of stopping the whole thing from sort of flexing is really this bottom cross member here, and I've used M5 bolts through here, of course, and also for mounting the servo and the main bell crank sort of steering mechanism. So it's all pretty robust with, you know, these Loctite, or not Loctite. I've got nylock nuts here, so they're not going to sort of go anywhere. But that's pretty solid, to be honest. Like I mean, obviously it's not perfect, but I'm applying a fair bit of pressure there and I'm not getting much movement. So that's really good. Obviously I need to redesign this to actually retain the outer race properly. And then I also need to reduce the scrub radius here, which will happen at some point. But right now, that's where we're at. I will take you through the electronics at some point. This is KiCad that I used to design the PCB, and that's obviously the layout. And then I've got the schematic over here, and I can take you all through that at another point. And I've sort of learned enough about KiCad to be dangerous and build something, and that obviously worked for the JLC PCB guys. So that's where we're at. So I wanted to give you a quick update. This is a bit too long again because I ramble, but hopefully this is starting to look interesting to everybody. This is starting to look like a real rover to me, and I'm pretty happy with the geometry for testing and the mechanical sort of stiffness and structure here. And the PCB, I think you agree, looks pretty damn nice. So the next video will be hopefully this powered by a 6S battery with everything connected, the 2 RoboClaws, the 2 servos, the ESP32 hanging off the 5-volt rail, and the entire thing doing something pretty simple like going forward and backwards and maybe turning around in circles or something. So that's the goal for the next video update. But I wanted to give you an update because it's been a while. And please follow along and subscribe and give me some comments and show me what I should be doing differently and better. But thanks everybody for joining on the journey. See you in the next one.